In this video, we are going to find positive integers a and b, such that for powers a to the power of a and b to the power of b, one is the fifth power of the other. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. To solve this problem, I am going to consider the greatest common divisor, GCD, of a and b. So by looking at this number, then I can write a as the product of common divisor and some other positive integer, say big A, and do the same for b. But now these two new positive integers are coprime, as in they do not share any common prime factors, and so this makes things easier. Now if I put this back into our original equation, then I will have d times big A all to the power of 5 times the same number, and d times big B all to the power d times big B. Then I can simplify by removing the d power. This can be removed, and then I can further simplify by putting the powers of d together. So then d to the power 5a times big A to the power 5 times big A equals d to the power big B times b to the power big B. And so we have power of big A over power of big B equals d to the power big B minus 5 times big A. So now with this equation, and we know that all the bases, big A, big B, and big D, are positive integers. Now, under normal circumstances, then the right side should be a positive integer, but now somehow it's equal to a fraction. So maybe I should divide into cases and try to break down into some special cases. For example, say whether a or b is equal to 1, then then this equation will be easier to consider. So now I have 3 cases. The first case is that if both are larger than 1, then the left side will be really a fraction, like not an integer but still rational. Then the only option for the right side is that the exponent big B minus 5 big A is a negative number. So then some kind of reciprocal will occur, and then there's a chance for us to have a fraction. That means B is less than 5 times big A. But then if we do a reciprocal on both sides of this equation, let me label with a star. But from the star, if I do reciprocal, which looks like this, we can draw a same, we can make the same deduction, which means 5 times big A minus big B is less than 0. And this tells that 5A is less than B. But apparently these two inequalities contradict each other, so this case is not possible. Now if this is not possible, then we have only 2 cases left, which are either A equals 1 or b equals 1. For each of the cases, we can simplify our equation star, which is 1 over b to the power of b equals d to the power b minus 5. Now there are two things that this can imply. First is that if b is indeed larger than 1, then I can say that either b is larger than 1, and so b minus 5 is negative. Or we just have b equals 1, and then we know that d equals 1. Now for the right case, we can quickly say that therefore a and b are both 1. It's indeed valid, because then if we go back to our original given equation, then both sides will be equal to 1. But for the left case, then since big B is also an integer, then we know big B is either 2, 3, or 4. Then we'll just try them one by one. If big B equals 2, then 1 over 2 squared is 1 over 4 equals d to the power minus 3. But that's not possible, because that means d cubed equals 4. So no solution. If b equals 3, then for the left we have 1 over 3 cubed, which is 1 over 27. And that equals d to the power minus 2. So that means d squared equals 27, non-integer solution. And finally, if b equals 4, then 1 over 4 to the power of 4 is actually 256, and that equals d to the power of 4 minus 5, which is minus 1. And then that means d equals 256. And from this, we can say that small b is 1024, because it's 256 multiplied by 4, which gives this number. And from this we can say that a is equal to d is 256. If you check, it's indeed a valid solution. From this, you can write it in powers of 4. Four to the power of 5 times 4 to the power of 5. And for b to the power of b, no bracket needed. And they are equal. So now we have two pairs of valid solutions. As for the other case, when big B equals 1 instead, from our equation star, we can say a to the power of 5a equals d to the power 1 minus 5a. Then from this we can say either as d equals 1 and then big A equals 1, this is still valid, or if d is not 1, then since the left side is an integer, then we must have 1 minus 5a, okay, d larger than 1, and 1 minus 5a is also positive. Or even if I allow it to be 0, then we still have a is less than or equal to 1 over 5. But that's not possible, because for positive integers, this big A must be at least 1. So there's no solution for this part. And for the case if d equals 1, then both small a and small b are equal to 1. And we actually have obtained this already. So that means altogether, our final solutions are either both equal to 1, or A is 4 to the power of 4, and B is 4 to the power of 5. Of course, you can say this as 256 and 1024. So these are our final answers. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.